name is Amit Kumar Manti. So let's go through the particular question of today, which is 1 plus cos pi x by divided by x minus 1 whole square when limits x tends to 1. So how we'll solve this particular question? Previously, in our previous video, what we have seen that how we will solve 1 minus cos kx by x square. We have seen this. The answer for this type of equation is k square by 2. But now in this new format, what has happened? It is 1 plus cos pi x. Previously, it was 1 minus. It is now 1 plus. And also in the denominator, it was x square, which was equal to the factor that has been multiplied with the k. But here, the value that is being multiplied with the k is x. And in denominator, it is x minus 1 whole square. So what has happened? The format is different according to our general known format. So what we want to reduce this original equation to our with our known format so that we can find our answer. Clear? That is our goal. Now, before proceeding forwards, let's first revise few of the trigonometrical identities, which is cos 180 minus theta equals to minus cos theta. That is one of the trigonometrical identities. If you have not understand how this identity came into existence, let's first go into the quadrant circle. Yes. So if I'm drawing a quadrant circle, this is first, this is second, this is third, and this is fourth. Now, if I'm finding out, let's find out theta. Yes, this angle will be my theta, let's say, and this angle will be my minus theta. Correct? What is theta? Theta is the angle made with a positive x-axis. So this one will be plus theta, and this one is minus theta. Now, what is pi minus theta? That means with minus theta, I have added 180. Correct? So with minus theta, which is presenting on this particular line, I have added 180. Yes. So it will complete semicircle. It is reaching on the second quadrant. And we know that in the second quadrant, only sign is positive. So for that particular reason, the cos pi minus theta becomes minus cos theta. Yes, why does this minus sign come into existence? Because the angle is now present in the second quadrant, and in second quadrant, cos is negative. Clear? So this is our main equation. Now let's reschedule this equation and find out a better equation for our understanding. So if I take this minus sign to the left hand side, it will become cos theta equals to minus cos of pi minus theta. Is this clear? Correct. Now, if I can compare this particular equation with this, can I say that theta to be as pi x by comparing with the original equation? Yes, in that equation, what can I write cos pi x as? I can write it as minus cos pi minus pi x. Yes, so what I have done here, I have replaced the theta with pi x. Correct? So what I can write instead of cos theta now, minus of cos pi minus pi x. Clear? So let's go to the next page and try to solve using the further steps. Okay. Now, in this situation, you can see what I have written. 1 minus cos pi minus pi x. I have updated the value here. You have understood why I have updated the value, because cos pi minus theta is minus cos theta. That's why I have replaced the value. Now let's take the pi as common here. So if I take pi as common, then it will become cos multiplied in the bracket pi into 1 minus x by x minus 1 whole square. Correct? If I write it in a better format here, it will become 1 minus cos pi into 1 minus x divided by x minus 1 whole square. Now, if I compare this equation with the previous equation that I have solved, which is 1 minus cos kx divided by x square. In this equation, what is happening? Is this x, this is the square term of that particular term. If this term is x, the denominator is the square of that particular term. That is our equation here. Yes, you can compare that equation that here the numerator is, we are multiplying pi with 1 minus x. Yes, so in this particular equation, if I compare what is happening, k value is pi, k equals to pi, and here the x value is 1 minus x. Yes, or I can also say that it is x minus 1. Clear? So now after updating this particular value, what I can know, if in the denominator it is x minus 1 whole square, I can also write it as 1 minus x whole square, because a minus b whole square and b minus a whole square both are same. Correct? Now, if you look into this particular equation, what I can see, this is the format, it has been reduced already. Now, can I update this particular equation? What is my answer in this particular format? It is k square by 2. So what I can do, 1 minus cos pi into x minus 1 divided by x minus 1 whole square. Yes, either you can write it as x minus 1 or you can write it as 1 minus x. Anyway, it is fine. Correct? So why it is fine? Because the numerator it is x minus 1 whole square. If you want to equate the numerator with the denominator, what you can do, instead of x minus 1 whole square, you can write it as 1 minus x whole square. Yes, any of the particular equation is also right. Why? Because in square terms, if you replace either of this equation, it doesn't matter, because it is the absolute length. Clear? So in this equation, the answer will, if this is the k, the answer is k square by 2, according to our previous equation. Yes, so you can see the answer here. In this equation, what is k? K is the value pi here. You can see this is the value of k here. So the answer will be k square by 2, which is in this equation, it is pi square by 2. I hope this is clear. Correct? Okay then. So yeah, that's all from my side. Thank you. Take care. and we will meet in the next class. And you can find the solution of this particular question resources in the description. The PDF link will be present there, and do check out our social media handles. So yeah, thank you. We will meet in the next class.